Hi friends, welcome to the channel JIB and CIB Made Simple. Today in this particular video, we are going to discuss our CTP Certified Treasury Professional Memory Based Question and Answer. So in our channel, you will see some 6 to 7 videos, separate videos covering the memory based question paper of the entire 2025, starting from January to the December. If you have not gone through that series, I have provided the link of the playlist in the description section. I request you to please go through those videos that will help you guys see the important topics from where questions have been asked in the examination, and you can prepare accordingly, and obviously this will help you to secure good marks. So let's get started with our first question in today's session. So the first question is basically, it is about Greenway Energy, right? So what they are saying that, Greenway Energy, it is a renewable energy firm. They issued a 10-year corporate bond 4 years ago. The detail of the bond at the time of issuance were like this: face value $1 lakh, coupon rate 8%, maturity 10 years, right? And currently the market interest rate for a similar risk profile bond have risen to 10%. As a result, the bond is trading at a discount in the secondary market. And investor Sara is considering buying this bond at the current market price of $920. The bond now has 6 years remaining until maturity. So the first question is asked. So this is a set of two questions. What is the current yield of the Greenway Energy bond based on Sara purchase price? So first of all, what are the data that have been given? Let me just write it down. So data they have given you is the face value. So FB, let me write it down. Face value they have given $1,000. Okay. Coupon rate they have given how much? Coupon rate is 8%. Okay. And current market price is how much? Current market price they have given, how much is they have given current market price? $920. Right. Current market price they have given $920. Okay. And remaining maturity is how much? 6 years. Okay. And Sara want to buy this bond at $920. So we need to find the current yield. So how to go about finding the current yield? So what is the current yield? Current yield means, annual return. Whenever I say current yield, it means, annual return based on the current market price. So the formula is very simple. To compute the current yield, what you need to do? In the numerator, you write the annual coupon. In the numerator, you write the annual coupon. And in the denominator, you write the current market price. That's it. So what is your annual coupon here? So as you can see, the annual coupon they have given is, yes, first of all, let's compute the annual coupon. So it is very simple. Coupon rate have been mentioned 8% and face value is $1,000. So obviously 8% of $1,000. So that would be how much? I think it will be 80 rupees, $80. So $80 is the annual coupon, right? So annual coupon is $80. Just apply the formula. So this current yield will be 80 divided by 920, isn't it? 80 divided by 920. What is 920? 920 is the current market price. So 80 divided by 920, that will give you 8.70%. Right. So the correct answer to this question is 8.70%, option number C. So current yield of the Greenway Energy bond is 8.70%. I hope it is crystal clear. So whenever a question asks you about current yield, there is a trick to remember. You can think about it like coupon over current. Coupon over current. So just remember the formula: coupon divided by current price. Right? C over C. C over C. That's it. So coupon over current. That is the formula for computing the current yield. Now let's have a look at the second question. So the same data, you have to use the same data. You have to apply the approximation formula and you have to tell what is the YTM or yield to maturity if the Sara hold the bond until it mature in 6 years. Option they have given 9.15, 9.72, 10.05, 10.42. So YTM, the question is regarding the yield to maturity. So what is happening here, Sara buy the bond for $920. Face value they have given is $1,000. Right. Coupon rate is how much? 8%. And 6 years remains till maturity. So time till maturity how much time is remaining? I think it is 6 years, right? Please understand. So basically, we need YTM if she hold it till maturity. So what we need? We need YTM if she hold it till maturity. YTM is obviously, if you are holding till maturity, then only YTM is comes into picture. So what is YTM? You know what is YTM? YTM is the total return. YTM is the total return that Sarah will earn. Total return that Sarah will earn if she keep the bond till maturity. Right. So YTM includes annual coupon. It includes annual coupon plus it also includes the capital gain. So it includes both the thing. Right. So what is the approximation formula for YTM? Let me tell you. The approximation formula for YTM is like this. C plus F minus P upon N upon F plus P divided by 2. Right. So this is the formula. This is the formula for, approximation for YTM. What is C? C is the coupon, annual coupon. So annual coupon is how much? Just now we have computed. I think it was $80, right? So annual coupon is $80. What is F? F is the face value, right? So face value, I think they have given $1,000. What is P? Purchase price $920. What is N? Number of year till maturity. So number of year till maturity is 6 year because 6 year is remaining, right? 6 year. So now let's see. Let's plug the value. So coupon we know coupon is $80. So first of all, let's come to capital. What is the capital gain per year? See, face value is $1,000 and purchase price is $920. So 1,000 minus 920 over 6 year. So that will be 80 over 6. That will be near about 13.33. So what is our numerator? So numerator is if you look at the numerator. So numerator is 80 plus 13.33, right? 80 plus 13.33, which is 93.33. And what is our denominator? Denominator is the average price. Denominator is the average price. What is the average price? Which is the face value plus purchase price divided by 2. That is equal to 960. So what is YTM? YTM is the numerator divided by denominator. 93.33 upon 960, which is equal to 0.0972, which is equal to 9.72 percentage. So the correct answer is option number B. 9.72% is option number B is correct. So this is how we compute YTM. So one trick to remember the formula for YTM is simple. Think of coupon plus gain over, right? Think of coupon plus gain over average price, right? Now friends, we will solve a practical question on forward rate agreement. So let's get started with the question. So first of all, understand the question. What is happening here that Apex Manufacturing, which plan to take out a 10,000, I think it is not 10,000, it is 10 crore dollar floating rate loan in 3 months for a duration of 6 months. To protect itself against a potential rise in the interest rate, Apex enter into a 3 into 9 FRA with a bank. And some data have been given. Notional principal is the same. So because you can see it is 100 lakh, or you can call it 1 crore, right? Same thing. And FRA rate they have given you 5.50 percentage. Day count convention is 360 days, right? So after 3 months, what happened? The market reference rate, which is 6 month LIBOR, is found to be 6.25% per annum. So the question they are asking you, what is the settlement amount that Apex Manufacturing will receive from or pay to the bank? So that is, you have been asked to compute the settlement amount. So option they have given: Apex pay $36,215, Apex receive $36,373, Apex receive $37,500, Apex receive $36,364. So these are the 4 options that they have given you. So this is the question. Let's understand. Let's write down the key points. And you are, I think you are familiar with the formula that we will use. So as you can see, notional principal is given to you is nothing but 100 lakh. Okay, and FRA rate has also been given. What is the value of FRA rate? 5.50 percentage, as you can see it here. Yes, you can see it is 5.50 percentage. Third point is that they have also given the market rate. How much is the market rate? Market rate, it is linked to 6-month LIBOR, which is 6.25% per annum. The market rate and this FRA rate. So what you can see, so please compare the market rate and FRA rate. So as you can see here that the market rate exceed the FRA rate, isn't it? Market rate is exceeding the FRA rate. So what does it mean? Since the market rate is higher than agreed, so this is the agreed rate. So FRA rate is the agreed rate that both these parties agreed, and the market rate is higher than the FRA rate. So what will happen? So in this case, what will happen? In this case, basically the FX will receive money from the bank, isn't it? FX will receive money from bank. Okay, since market rate is exceeding the FRA rate, so Apex will receive money from the bank. So what is Apex? Apex is a manufacturing is firm, right? It is a manufacturing firm, as you can see. So it will receive money from the bank. Now the question is how much? That is what the question is asking you. What is the settlement amount, right? How much they will receive? So since the market rate is higher than the agreed rate, FX will receive money from the bank. Now the question is, let's compute how much they will receive, isn't it? So how to compute that? So it's very simple. First of all, what you do, you see the differential. First of all, you calculate the differential, right? You calculate the differential. So what is the differential? Just see the difference. This is 6.25% minus 5.50%, which is equal to 0.75%, or you can call it 0.0075. Okay, so that is the interest differential. You can call it, to be more precise, you can call it interest differential. Second thing is calculate the future value of payoff. See the steps. This is exactly the same step you have to follow. So second thing you have to compute is the future value of payoff. Future value of payoff undiscounted. Undiscounted. So what will the future value of payoff undiscounted? So it's very simple. First of all, you take the 1 crore. Okay, and then you write 0.0075, which is the differential rate, and for how many days they have given. Let me show you. So the days they have mentioned, obviously you have to day count 360 days, but in this particular question, after 3 months they have mentioned, right? After 3 months the reference rate is found to be. So 3 months means what? How many days? Okay, so what is the settlement amount manufacturing will receive? And floating rate also. Okay, for duration they have given 6 months. Here you can see duration is 6 months. So friends, duration they have given 6 months. So 6 months is equivalent to, I think it 180 days. So we have to compute the future value of payoff on the basis of this 180 days. 180 divided by 360. Okay, so that will give you $37,500. That is the future value of payoff, right? $37,500. Now what we need to do? We need to discount to the present value. We need to discount it to the present value. How to go about discounting to the present value? So you know it very well that FRA is settled at the start of the loan. FRA is always settled at the start of the loan. So we discount using the market rate. What is the market rate? The market rate is now 6.25%. So use it for discounting. So let's finally find the settlement amount. So settlement amount, what is the formula to compute settlement amount? Let me write it down. So settlement amount is equal to 37,500 divided by 1 plus 0.0 0.0625 multiplied by 180 upon 360. That will give you 37,500 upon 1.03125, which is near about 36364. That's it, right? So this is the amount that Apex will receive. This is the amount that Apex will receive, 36364. Let's see the option that they have given. So pay 36215, no, wrong. Option number B, receives 36364. Yes, D number is correct, right? So what is the memory trick for FRA settlement question? The memory trick is very simple. Let me just write it down. So what you have to see? So first of all, you have to calculate, you have to see the difference. First of all, you have to write down the difference multiplied by principal and multiplied by time, right? Difference principal and time. That is what we have done here in this particular formula, as you can see. So this is our difference, this is our principal, and this is our time, right? So rate difference multiplied by principal and time, and then finally we have to discount it using the market rate. This is what we have done, discounting using the market rate. So just remember the keyword DPT. This way you can remember it. DPT, which means discount after principal time calculation, right? So quick summary, just have a quick let's look at the quick summary. First thing, we have to compute the FRA settlement is the present value of the interest difference. So if you want me to write a single formula which can capture everything, so first of all you write the notional amount multiplied by market rate, subtract the FRA rate, right? So these are the rates, multiplied by days upon 360 and divided by what, 1 plus market rate into days upon 360. So this is the formula that you can use to compute the settlement amount. So in this particular case, the final settlement amount that we got is how much? That is how much? 36364. Option number D is the correct one. I hope this question is crystal clear now. Every aspect we have touched one by one. Friends, let's switch our focus to the third question. Friends, let me tell you, if you are obviously preparing for CTP and if you want last minute revision points, all unit wise theory, unit wise MCQs, such kind of previous year memory based question, you can WhatsApp me on this number for more detail, or you can check out our course on CTP, using which many aspirants have cracked the paper on the very first attempt. So now let's see the third question that we have. So this question what is happening, that they have mentioned that Apex agreed to borrow at 5.50%. Okay, earlier also that was the FRA rate, right? So what was the, so this question is also second part of the earlier one. So FRA rate, it is the same, which is 5.50%. And that means, this particular Apex agreed to borrow at 5.50% using FRA. But what happened? Let's have a look. So in this case, what happened at the end of the 3-month period, right? It has fallen to 5%. So actual 6-month LIBOR is 5%. So in this case, let me write it down. This is the FRA rate. And what is the market rate? Market rate is just 5%. So now you can check in this case that FRA rate, so you can check out easily that FRA rate is higher than the market rate, right? Or market rate is lower than the FRA rate. Both way you can say the same thing. So who pays whom? That's the question. Who pays whom, right? So since Apex logged in higher rate, isn't it? They have logged the rate 5.50% higher rate. So Apex compensate the bank for the difference. So because they logged the higher rate, he says that I will buy at this rate and the market rate is just 5%. So obviously what Apex will do, Apex will pay the bank and Apex will compensate the bank. Apex has to compensate the bank, right, for the difference. So let's compute step by step. Okay, so what you have to compute? You have to compute the interest rate difference. How to go about computing it? Let me explain. So we have to compute the interest difference. See how to go about computing the interest difference. So you can see they have mentioned that 6-month LIBOR has fallen to 5%, and the FRA rate. So just find the difference, right? FRA rate is how much? 5.50. Market rate is how much? 5%. So difference will be how much? 5.50 minus 5%. That is equal to how much? 0.5%. Now second thing we have to compute is the undiscounted payoff. What is the payoff? So the amount is the same, 1 crore. So amount remained the same and just multiply it by 0.0, because you can convert this percentage to decimal, it will be 0.005, isn't it? Multiplied by 180 upon 360, right? So just after computation you will get $25,000. That's the payoff, right? That's the payoff. And the final third step which we have to apply here is the discounting, discount to the present value, right? Discount to the present value. So if you discount it to the present value, the final settlement amount will be how much? $25,000 is how much? 25,000 in the numerator, in the denominator 1 plus 0.05 multiplied by 180 upon 360. तो ये आपको दे देगा वैल्यू 25,000 divided by 1.025, that will be $24,390. That will be our discounting value. So how much the bank received? Bank received $24,390. That's the correct answer. So Apex option they have given, Apex would receive a settlement payment. No. The bank would receive, yes, correct. B number is the correct one. Bank will receive how much? 24,390. Now let's look at the next question that we have. So the next question is related to the duration, one of the super important topic from your question are asked every year in the examination. So let's do one practical question on duration. So what they have given is that, Zenith Capital, right? So Zenith Capital, they have a you can see 15-year bond with 7% coupon, and the coupon is paid annually. And also they have given the face value of $1,000. Face value they have mentioned is $1,000. So obviously, as you can see, they are currently trading at par value. They are trading at the par value. So what is the YTM? YTM is also 7%. So see, this is the peculiarity of the question, because they have mentioned the bond is trading as a par value. So that means YTM is also 7%. Right. So let me just summarize the key point. You can see Macleod duration is this much, modified duration is this much, and convexity also they have given. And one more thing is that basically David is preparing for the potential shift in the market where interest rates are expected to increase significantly by 100 basis point. So let's write down the key points which we have seen here. So let's summarize. Basically 15-year bond they have given. 15-year bond, first point. Second point is the coupon they have given 7% coupon. Third point is face value they have given. Face value is how much? $1,000, right? And clearly they have given that trading at par. So YTM they have given 7%, right? So YTM is 7%. Then let's compute the what is the expected percentage change in the bond pricing using the modified duration. What the question is asking? The first question is we have to impact of duration. So using the modified duration only, what is the estimated percentage change, right? Estimated percentage change in the bond price if the interest increase by 150 basis point. That's the question. So now let's first of all understand what is the meaning of this modified duration. Let's first of all understand the meaning of the modified duration. Whenever I say modified duration, it tells us how sensitive the bond price is with respect to interest rate change. How sensitive the bond price is with respect to interest rate change. Please understand. So what is the formula to compute modified duration? So formula is very simple. As you can see, percentage change in price is equal to negative of modified duration multiplied by change in yield, isn't it? Now one thing you can see here that they have given the negative sign. What does it indicate? Negative sign because price and yield, price and interest rate they move basically opposite. That's why negative sign is there. So let's plug in the value. Percentage change in price is equal to minus of MD. How much MD they have given? Let me show you. So MD they have given is just wait a minute. So I think modified duration, yes, here you can see 9.11 year. Okay, 9.11 year. Let me just write it down. So so this minus 9.11 multiplied by percentage yield. Yield, as they have mentioned, clearly mentioned that yield have, yield where the bond price, the interest rate increased by 150 basis point. Yes, so they have mentioned 150 basis point, right? So you can write the yield as, yield as 0.015. That's 150 basis point. Okay, so 0.015. So either you can write, see, 150 basis point means what? 150 BPS means, 1.5%, or 1.5% means just divided by 100, it will be 0.015. So that is how 150 BPS is equal to 0.015. Right. So I hope this is crystal clear right now. So now just plug in the value. So what is the final value we are getting? That we are getting is the minus 0.13665. Right. Or we can also write it. We can also write it like another way to write it like in terms of percentage. Right. Minus 13.67%. So what we are observing is that, bond price is decreased by 13.67%. So if you look at the option that we have, yes, B is the correct one. 13.67% is the correct one. Right. I hope this is crystal clear. So what we have learned from this question. So minus duration into yield change first thing. So whenever the question asks you to compute the price change, just write minus D into delta Y. That's it. Right. So let's quickly revise the key points. So what I told you that this modified duration represent the sensitivity of bond price to interest rate change. It shows the sensitivity of what? Bond price with respect to what? Interest rate change. Second thing I told you that please understand, if the rate increases, interest rate increases, bond price will go down. That's why negative sign. In this particular case, interest rate increased by 1.5%. So price dropped by how much? 13.67%. That is what we are observing. Is it clear? I hope it is clear. Now let's do one more question based on convexity adjustment. Very, very important. So the question is again, interest rate increased by 1.5 percentage or 150 basis point. And convexity they have also given you. How much is the convexity? Convexity they have given, I think, yes, you can see convexity they have mentioned is 115.33. That is the approximate convexity, isn't it? So first of all, let's understand what is the meaning of this term so-called convexity. What is the meaning of this convexity? First of all, let's understand. So what is the convexity adjustment? First of all, let's understand what is the meaning of convexity. Convexity measures the curvature. It measures the curvature of the price yield relationship. Right? Curvature of the price yield relationship. So when rate change a lot, the actual price change is slightly different from the straight line estimate given by duration. See, obviously, whenever you compute the duration, whenever you use the duration to compute the price change, so duration assume a straight line estimate. But in actual, what happened? It follow the curvature, right? So when the rate changes a lot, so suppose interest rate is changing a lot, what will happen? The actual price changes slightly. So when the rate changes a lot, what happened? That the actual price change is slightly different. So price change is slightly different from what duration computes. Okay. So the what happened, for suppose we have a positive convexity bond, suppose we have a positive convexity bond. So in that case, what will happen? Actual price is higher than the duration estimate, right? So in this case, actual price is higher than the price estimated by duration, right? So what we do, we add the convexity adjustment. Please understand, this is a very important thing I'm talking about. So in this case, we add the convexity adjustment. The reason being, yet actual price is higher than the price duration. Now you may ask me, what is this formula for convexity adjustment? Let me write it down. So formula for convexity adjustment is just simple. Half of convexity into delta yield square. So half of convexity into delta yield square. Just plug in the value. Half means 0.5. What is the convexity? 115.33. What is delta yield? I think it is 0.015 square, right? 150 basis point. So if you compute it, this will give you 0.01297, or approximately we can say 1.30%. So the correct adjustment is plus, obviously it is plus 1.30%. So option number B, I think, is correct. So yes, B option is correct, that is 1.30%. Now there is a memory trick to remember the formula for computing the convexity. What is the memory trick? Let me write it down. Half, first of all, write half multiplied by convexity and take the square of yield. Take the square of yield change. So half of convexity multiplied by square of yield change. Now you may ask me why we have done the square. So because convexity deals with curvature and convexity never deals with a straight line. I already told you convexity always deals with what? Convexity always deals with a curvature. And convexity never deals with a straight line. That's why a square. So adjustment, whenever the question asks you to compute the adjustment, just remember the simple formula: half into convexity into delta yield square. So let me quickly summarize the key learning from this question, that convexity improve the accuracy of price change estimate for a larger interest rate move. Yes, the one of the biggest advantage of convexity is the improving the accuracy. Is improving the accuracy. Second thing, I told you the formula which is written here, half into so that's the point. Now second thing is improving the accuracy. Formula just I told you, half into convexity into delta yield square. And I told you positive convexity means what? Adjustment is added. Positive convexity means what? Adjustment is added to the duration estimate. In this particular case, the adjustment is 1.30%. Now let's look at the third question of the same data. From the same data, you have to compute the third question. Very good, right? So let's compute the impact of duration and convexity adjustment separately. So now friends, convexity. So now let's combine the impact of duration and convexity adjustment separately. So earlier what we have done, in the first question, what we have seen, in the first question we have seen the what is the impact of duration, right? And second question we have seen the impact of convexity adjustment to the price change, isn't it? The same thing we have done. Okay, now let's combine both of them, right? So what is the situation is the same, right? The situation is the same. Let me write it down. What is the situation? So what we have seen is that your interest rate, just let me write IR, your interest rate increased by 150 bps, or we can say 1.50%. So we have seen that duration effect on price is that how much? Minus 13.67%. Let me show you. See, the first question we have done, right? The first question we have just computed that the effect of duration is percentage change in price 13.67% negative. And the second question, convexity effect, we have seen 1.30%, right? So duration effect minus 13.67 and convexity adjustment is how much? 1.30% plus 1.30%. Now the question is asking what is the total estimated what is the total estimated percentage change in the bond price considering both of the case. So duration effect, we already know that from the first question that bond price drop by negative sign clearly indicate that bond price has decreased due to the duration. And convexity adjustment from the second question, convexity add back plus 1.30% because the actual price is slightly higher than the straight line estimate. See what is happening, actual price is slightly higher than the straight line estimate. So that's why convexity add back 1.30%. So you combine both of them. So you combine. So total change is how much? So total change is, you just combine the effect of both the duration and convexity adjustment. So duration effect plus convexity adjustment effect. So that is how much, minus 1.3667. Let me write it down. Minus 13.67% plus 1.30% minus 12.37%. That's our answer. So what is happening ultimately, that bond price is falling. This negative sign increase that, bond price is falling by how much? 12.37%. Yes, B is correct one. So convexity, soften the blows of the interest rate hike. Without convexity, the drop was how much? Without convexity, the drop was, let me write it down. So convexity, what it has done, it has softened the blow of the interest. Without convexity, the drop was 13.67%. But with convexity, it is only minus 12.37%. So duration gives you the big picture. Convexity fine tune it. And the total change is the sum of both of them. Duration effect plus convexity effect, which is minus 12.37%. I hope it is crystal clear. Now, one more question based on the same data. This is the kind of case study which we are doing right now. Suppose the bond current market price is $1,000. What is the price value of the basis point? That's called PVBP. Very good question. So bond price they have given you. Modified duration already we know. So here we have to apply the modified duration data. So what is the modified duration data? Let me show you. Just wait a minute. Yes, 9.11 year. McLaw was 9.7%. Modify is 9.11 year. Right. So let's apply this 9.11 year. Okay. So first of all, let's understand the meaning of this so-called, PVBP, price value of basis point. You know the meaning of it. Let me explain. What is the meaning of this PVBP? So basically it tells us how much the bond price change in dollar. How much the bond price change in dollar when the yield change by 1 basis point. So basically whenever you talk about PVBP, it means, simple meaning is that how much the bond price change in dollar when the yield change by 1 basis point. So the formula is very simple. What is the formula to compute the PVBP? Let me just write it down, the formula. PVBP is equal to modified duration multiplied by price multiplied by 0001. So you may ask me why we have written this 0001. So this means, 1 basis point in decimal. So 1 basis point is, very well 0.01 rupees. Just divide it by 100. So 1 basis point. Just now plug in the value. So 9.11 is the modified duration. Price we have given 9.11 multiplied by 1000 and just multiplied by 0.0001. That will be how much? 9.11 multiplied by 0.1, which is equal to 0.911. So $0.91, right? $0.91. The PVP we have got is $0.91. Option number A is correct. So remember, whenever the question asks you to compute the PVBP, price value of a basis point, just do one thing. First of all, write the duration multiplied by price and multiplied by 0.0001. That's it. That is how you get the PVBP. So basically PVBP, let me summarize. It gives you the dollar impact of a basis